Okay, hello there again. So we got a fine medium problem of the data stream. It's a hard problem, but that's also upvoted many times and one more time for me. And so we got companies, there are a lot of companies that are using that kind of question. So I probably highly recommended to do that. So we got a stream like the data is flying like integer. We got a method add num that is introducing the new number to the container data structure what we have depends. And then we got a find medium function that is going to find the median in the array. So first of all, we need to know that the median is the middle element from the sorted array. So we need to some kind of mechanism that will sort it. So maybe let's do it like the super naive way, and we want to just sort it. Nums, let's do the nums. we wanted to just sort it, add it to array nums and num that add of num, and we are going to nums array collections that sort of nums, and let's see, is that going to work? So, and now if let's go with the var size is equal to nums dot size. So we are going to repeat all of those every time. And now if size modulo 2, so there's a so now we're going to return there's no medium, there's no middle element, so we need to like the arithmetic average from two middle elements. So we need to return and nums of get with the size by 2 minus 1, and going to be a sum, so we need to add it. And nums that get of size divide by 2, and just divide it by 2 just for beautifulness. Okay, and if there's an even number of elements, then return nums that get of size divide by 2. And let's see, is that a good solution? So this is super wrong solution. So what did I do wrong here? Say size. When there are two elements, so there are going to be a 0 and a 1. Why is that bad? Oh, so this is the issue. Let's run it. Okay, so we got it. It seems like LeetCode is accepting it. It's 1.5 seconds, so probably that's not acceptable in a real-time scenario. So when we got like millions of data, so we cannot sort it every time. So this is not pretty convenient. Okay, so we need to introduce some kind of a new idea, and the idea here is to create two heaps, and two heaps going to self-balancing every time we're gonna add it to the heap. And if we're going to have at the end we're always going to have a balanced heaps that have at their heads the numbers of the middle elements. So if the sum of those heaps elements are even, then we're going to have to take from the left heap the elements, and if they are odd, then I'm going to like divide it, take the two elements from the heap and divide by 2, sum it and divide by 2. So what's the idea here? So let me go, I just prepared it. So we got the max heap right here. I'm going to introduce the variables firstly on the max heap. And if max heap, and from the max heap, we're going to remove outsiders. So those big elements that's supposed to be in the min heap. So maybe, first of all, I should like said that this heap is representing the lower half of the sorted array, and this heap is representing the max, this is the rest, like the bigger half of the array. And in this element, we got the smallest element in the sorted array of the biggest half, and in that one, though, this element, we got the greatest element from the lower half of the sorted array. Maybe not sorted, but kind of sorted, because this is a heap. Okay. So first of all, we would want to have the element here, like we are adding the element to the heap, and then we're going to remove the outsiders. So those elements that is going to be on the left, on the right hand, right half of the array. So we're gonna remove it, like add it to this array. And if those arrays are balanced, so when their sizes are equal, then we're going to we're going to leave it as it is. But if it's not, then we're going to transfer it still to this heap. So let's see how it works right now. So we got it as 1. So now we're going to introduce it here, and everything is nice and dandy. So now we want to remove the outsiders. So we don't know still if there are any outsiders. So we're going to remove that one and place it here. We got one here. Okay. And this is not balanced because there's a bigger half here, and we want to have they're equal. So we're gonna still remove it from here and add it here. This is pretty confusing, but you'll just keep up with this. Okay, and then the next number is 2. Next number, we're gonna introduce it to the heap right here, and this is a max heap, so we need to like transfer it here and add it 2 here and 1 here. And now we're going to remove the outsiders. So now we can see that the outsiders are in the heap, because that 2 should be transferred to the biggest half of the array. So let's remove it and place it right here. And there's a 2 here. So now we have a balanced. All 2 heaps are balanced. So we're going to proceed with the next number, so 3. So we want to introduce the 3. So first of all, we're gonna push it to this heap. Let's go, yep. And that will be length like that. And remove the outsiders. So now we can see that this is not balanced, because this 3 not belonging to the left sorted array, left half of the sorted array. So let's remove it. We're gonna pop it off. And 1 is going to land here, and we are adding here the 3. So this is a the min heap is going to have a minimum value at the head. Okay. And now this is not balanced. Yeah, right. This is not balanced. This is 2. This is 1. So we're going to transfer it again here. So remove. There are going to be 3, and 2 needs to be added here. So remove 2, 1. Okay, so that was the process, pretty long process for 3. Now we got the 4. Let's add the 4. So we're gonna add it here. The max heap. 4, 1, 2. We got a max here, right? Or we need to remove the outsiders. Okay, outsiders. Yeah, okay. Those elements that are outside of the bounds of the first sorted half. Okay, so we remove it, the max. We need to heapify it, like get it balanced. So this is a 2, 1. Need to add the 4 here. This is minimum, so this is 3, so that's gonna land here. And this is balanced, so we're not going to do anything here. Okay, so as you can see, we got the middle element here and middle element here. and that is going to keep repeating, and that will finish the process. Let's finish the process and we'll see what is happening. Okay, so we're going to add 5. Let's add it here. So now we need to balance the heap. 5, 1, 2. Okay, and now we need to remove the outsiders. Okay, and so 5 is going to be removed from there, and let's go with the 5. So that was 2, 1. 5 is going to being added here. Okay, and now we're good. This is not balanced, so we need to transfer some elements to the max heap. Remove it. Let's remove this is we're pulling from the first element, so yeah. And that was the mean heap, so this is a 3, and that's 4. When we are adding 5 here. Oh no, we're adding we're removing 3 from here, and this is a 4. Say 4 and 5. Oh yeah, we need to be focused here. And the max heap, we need to add 3 here, so we need to remove that one. Add 3 and 2. Okay, so that's the process, and as you can see, we have that one, the middle elements on the heads of the heaps. And we can just take, if this is the even number, we can just take it from the max heap, and this is a 3. If we would add the 6 here, then the heap's gonna be self-balanced, and there will be 3 and a 4 here, and the 6 would eventually appear here. And there will be 3 plus 4 divided by 2. That would be 3.5. And let's go to the code. So we need to first of all initialize the max heap, and that would be priority queue of integer and collections dot reverse order as far as I'm concerned. Okay. And now we're going to introducing the min heap. Okay, let's add the number here, and now we're going to offer the number to max heap offer, and I'm going to be none. And let's remove the outsiders, so that's going to be min heap offer max heap, so that poll first element. Okay, and now we need to balance it. Balance. Okay, max heap dot size is equal to min heap dot size if it's okay, if it's not equal. It's equal, then we're going to be adding here and max heap dot offer min heap dot poll. Okay. And just let's find the medium. So if max heap dot size is equal to min heap dot size, there's a need for being less. Okay, and and then return max heap dot poll peak. So first of all, we need to add it 2 elements, min heap dot peak, and that will be divided by 2.0. Okay, and if we are even, when there are even numbers, then max heap dot peak, and that should be like it. Let's try to do it. Okay, we're good. Okay, and we're done. We're pretty boosted the performance pretty good. So if you like it, subscribe, give it a thumbs up, and yeah, bye bye. I'm going to the next one.